Hi, today we will discuss about structure of an atom. J. Thomson was the first one to propose a model for the structure of an atom. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like currants, dry foods in a spherical Christmas pudding. We can also think of a watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere like the seeds in the watermelon. Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude. So the atom as a whole is electrically neutral. Although Thomson's model explained that atoms are electrically neutral. How the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil like this, like this, like this, like this. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4u, the fast-moving alpha particles have a considerable amount of energy. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Particle scattering experiment gave totally unexpected results. Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. On the basis of his experiment, Rutherford put forward the nuclear model of an atom, which had the following features. First one, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The second one, the electrons revolve around the nucleus is well-defined orbits. The third one, the size of the nucleus is very small as compared to the size of the atom. Drawbacks of Rutherford's model of the atom. The orbital revolution of the electron is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. We know that the atoms are quite stable. Bohr's model of atom. In order to overcome the objections raised against the Rutherford's model of the atom, Niels Bohr put forward the following postulates about the model of an atom. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom, while revolving is discrete orbits, the electrons do not radiate energy. These orbits or shells are called energy levels. Energy levels in an atom are shown in this figure. These orbits or shells are represented by the letters K, L, M, N or the numbers N is equal to 1, 2, 3, 4 and on. Neutrons. In 1932, Chadwick is discovered another subatomic particle which had no charge and a mass nearly equal to that of a proton. It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. A neutron is represented as N. The mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus.